Please wait 5 more minutes, then we'll start. Good afternoon, everyone. I'm audible.
Yes,
Okay, thank you. First of all, thank you for joining the session. A warm welcome to this exciting hands-on training for device and material simulation using rescue and nanotical software organized by Impulse Technology. I am Ujjwal Pratap Singh, an application engineer from Impulse Technology, and I'm thrilled to guide you through this 6-day training program designed to material and device with practical skill in nanoscale material and device simulation. Whether you are researcher, student, or professional, this training will help you master cutting-edge tools for simulating material and devices. Our goal is to help you with the skill to perform simulation of material and nanoelectronic device using rescue and nanodical tool, supported by easy to use device Studio GUI. And our partner with Nano Academic and Fluxim. Nano Academic provide nanoscale material and device simulation tool, which created carbon nanotube, graphene nanoribbon, magnetic tunnel junction, crystal, and molecules. And second one is Fluxim, which provide solar cell software for OLED simulation software, perovskite, tandem, organic, solar cell, OLED. In today's session, we basically go through the Rescue and Device Studio GUI, get familiar with Rescue and the Device Studio graphical environment, and basically overview of the Rescue software, their feature, architectures, capability, create the SCF field, band structure, density of state, and type of the system and simulation supported. In Introduction to Device Studio GUI, basically we walk through the tool, structure building tools, wizard for the DFT setup, and create a basic silicon unit cell and perform SCF and band structure analysis. In the second day, we basically learn about the structure relaxation, basically geometry optimization for the material and DFT density functional perturbation theory in the SQ. Basically learn about the relaxation process and DFT based property calculation, density functional perturbation theory overview, and phonon dielectric constant and forces, and structural relaxation workflow like convergence criteria, energy force minimization, relax a graphene sheet, analyze force, energy, convergence, and final geometry, and run a DFT simulation and interpret the result. In the third day, basically we go through the device simulation software where NanoDecal comes. Where in the third day, basically we learn about the two-probe device modeling and create and simulate two-probe device using NanoDecal. Basically go through the overview of nanodecay and NEGF, non-equilibrium gain function plus TFT, and two probe structure like left and right electrode plus scattering region, heat transport parameters like transmission, local density of state, effective potential, and build a two probe device like graphene structure with left electrode and right electrode and scattering region, and calculate transmission spectrum, density of state, effective potential, projected dose. At the fourth day, basically, we go through the molecular and graphene-based device simulation, where we can analyze complex device like molecular junction and dope graphene, where molecular device like benzene between metallic electrode, graphene-based device, nano-even, heterostructure, dope system, and computed parameters like IV characteristic, local density of state, local charge distribution, and simulate a benzene molecular junction and create doped graphene nanoribbon and extract transport properties. At the fifth day, we go through the advanced device example like PN junction and magnetic tunnel junction, model complex nanoelectronic and spintronic device as a silicon PN junction where band alignment, potential profile, doping effect, and magnetic tunnel junction structure, where we get spin polarization and spin dependent transport, perform SCF and transport simulation, and analyze potential barrier profiles, density of state, and magnetic movement, build and simulate silicon PN junction and magnetic tunnel junction, and extract spin transport parameters. At 6th day, we basically advanced tool like NanoDK Plus, Rescue Plus. NanoDK Plus is an advanced tool for the device simulation, where we can perform 1 lakh atom, and in Rescue Plus, 1 lakh atom for material simulation. Basically, NanoDK Plus set up for the large scale transport calculation, and Rescue Plus for the parallel DFT solver for the large system. And QTCAD basically is a quantum technology computer aided design tool where you can find properties like Coulomb blockade, charge potentials, Schrodinger solver, Poisson solvers, quantum dot, nanowire, and quantum well devices, and band structure engineering for the confined system. And SETFOS also for the optical simulation like light absorption, photonic structure, combine optical and electronic simulation for optoelectronics. Before moving to the demo part, let's go through the company overview. Our company was founded in 2008 by Professor Hong Guo and Dr. Lee. Basically, the molecular quantum transport software, which has been developed for 10 plus years, we enhance material development through advanced digitalization and modeling tool. Now, we are determined to address the emerging sector in the quantum computing revolution using QTCAD software. We have several unique tools to offer more in development about to be released like NanoDecal Plus, Rescue Plus, NanoDecal, Rescue, and QTCAD. Here you can see Rescue, real space electronic structure calculator is optimized to create a complete large scale DFT solution. Full set of features like Rescue is a state of the art general purpose CONSAM DFT package based on advanced numerical mathematics and parallel implementation. And it's come with DFT which allow computing all sort of responses, function like polarization, phonon, band structure, or optical properties. Their key features are basically written in MATLAB and C and focus on large scale system up to 20K atoms. DFT implementation like dielectric tensor, dynamical matrix, optical properties like dielectric permittivity, refractive index, Raman tool for the set tensor, spectrum, and intensity, advanced functional treatments such as DFT plus hybrid and DFTU Hubbard, and common analysis tool like density of state, projected density of state, local density of state, and band structure, band unfolding, charge analysis, nonlinear optical susceptibility, spintronics like collinear, non-collinear, spin orbit coupling, and phonon tools, finite difference phase, and large-scale CFSI solver. Basically, our software started as a college project, and in 2001, NanoDecal and NEGF DFT code by Taylor, then Northwestern University. Then in 2008, basically our Nano Academy technology founded. After that, in 2015, Rescue which will installed, then Device Studio, then Rescue Plus in 2022. Rescue is basically used for the material simulation software with DFT-based and density functional perturbation theory, where you can create and simulate your structure and find the properties like dielectric, charge, tensor, Raman properties, optical properties, dynamical metrics, and sophisticated approach effective for the different problems. And nanotical is used for the device simulation, where you can create your device and simulate and find the parameters like band structure, density of state, effective potential, charge analysis, and you can create 6 probe devices in NanoDecal also. Nano Academy technology provides advanced tools like you can create your structure, set up parameters in user-friendly way like SCF input parameter, basic settings, electrode, left-right, spin types, and realistic physical for a complex material like smart analysis. You're using transmission gap coefficient, and you can find effective potential also. And material properties like electronic, structure, optical, thermal, magnetic, electronic and thermal transport, and electron phonon coupling. Basically, you can create molecular device surface with interface builder, complex material, interface between two material with interface builders, and molecular devices like benzene molecular devices, two-dimensional devices for the graphene structure, also carbon-based material. You can basically rescue features are like LDA, GGA, meta GGA, exchange correlation function are present, and hybrid and collinear spin, non-collinear spin, and spin orbit interaction. You can see like LDA, local density approximation, GGA, meta GGA, and hybrid and partial exact correlation. Rescue features are like symmetry, structure relaxation, where you can optimize your structure, material, band structure, band unfolding, density of state, and projected density of state, local density of state, molecular population, and one-year functions. Rescue come with DFPT also, density function perturbation theory, toolbox for the response function like electric field, atomic displacement, and third order nonlinear response, and solver like CFSI, BICGS, and where you can find ion clamped dielectric constant, vibrational mode analysis like phonon band structure, and density of state, boron effective charges, low frequency optical properties like infrared intensity, complex dielectric permittivity, complex refractive index, energy loss, oscillator strength, and non-resonant Raman spectra like tensor, susceptibility, intensities, and electron phonon coupling, where matrix element, scattering times, and mobilities. You can see the accuracy benchmark also for the rescue software. You can see DFPT ion clamp dielectric constant with rescue, where carbon, silicon, aluminum, and silicon carbon, magnesium oxide with the accuracy benchmark and performance benchmark also. With PCFSI solver advantage with take lower memory requirement, algorithm inherently more parallel. Here you can see phonon band structure and density of state with comparison with experimental value. You can see phonon band structure for FCC diamond in the tabular form and large superset simulation diamond phonon density of state with supercell with 216 atoms. You can see the experimental and rescue parameters. It exact matchly. The FPT also low frequency, long wavelength optical property with hexagonal aluminum nitride. You can see the dielectric permittivity, refractive index, and their experimental value and rescue value. You can see, and IR intensity and oscillator strength, and infrared intensity like hybrid, organic, inorganic, and full phonon mode decomposition. And novel material study for the spectroscopy prediction and analysis. You can see the silicon nano study by DFPT method, where experimental measurement, then DFPT supercell and heterostructures. Rescue Plus basically for the large scale DFT, real space electronic structure calculator plus, written in Python and Fortran, very large scale system up to 1 lakh atom, friendly Python interface, ion dynamics, relaxation, molecular dynamics, and electronic structure tool, band structure, density of state, and projected density of state, Mulliken, band unfolding, and spintronics like collinear, non-collinear, spin orbit coupling, two probe non-equilibrium transport like nanodecade plus and transmission dielectric IV characteristics also. Rescue Plus used for the battery application like in car, buses with growing market in buses and auto bicycles and gradually saturated market like power tools, personal care, tablets, smartphones and growing market like grid energy, stationary energy storage, renewable energy and portable energy storage. Rescue Plus graphene as a battery material. You can simulate convergence acceleration using machine learning on two-layer graphene plus lithium impurity, twisted bilayer graphene with lithium interaction. This calculation, the energy minimization of twisted bilayer graphene and the computational efficiency also improved by adopting ML model. Battery material study using our machine learning tool like battery electrode material, molecular dynamics study, complex solid liquid interface, including 10 elements and close to 1,000 atoms, and complex ion dynamics and charge transfer require of into molecular dynamics. If you support technical support for the India, we basically India distributor for the Nano Academic and Fluxin, you can contact us. Let's move to the device studio. I hope everyone installed the device studio.
Yes.
Everyone received like everyone received mail like this. Firstly, we have to go to the disk drive, then download. You can see here download anywhere. Click on the download anywhere and download to the download folders and save. After that, come to the download, right click, extract all, and at a specific location, you can browse at your location and extract all. After that, after extracting, move to the unzip folder where your folder has been extracted. Go to the device studio. In the bin folder, also paste the license file. You can see a license file, download it. Copy the license file, then come to the device studio. In bin folder, paste the license here. Here you can see the license file. And here you can see the application file, that device studio.exe. Double click. It will open the software. Here you can see the GUI of device studio. It's asking for the create a new project or open an existing project. Let's create a new project. Okay. And give the name. This is a GUI for the device studio. You can see here project. Our project folder has been shown this here, and the properties like the properties of atom and elements. And you can see here the job manager where SCF input running queue condition and all it been shown here. At the top, you can see file menu bar, the file, edit, view, build, simulator. You can see in simulator like nano decay and rescue, window and help. In help, you can also see getting started with device studio. You move to and open it. You can go through this. It basically define everything like menu bar, every tools of the device studio GUI. You can see the file option. In file option, you can see new project. You can create your new project by clicking this. It will pop up and give the name of your project and save. After that, you can open your existing project also and save project also. Here you can see the new, you can create your device, crystal and molecule. At below section, import option, you can see import local and import online. It imported basically your material file. If we move to the import local, our device should provide multiple material file. You can see like organic material, 3D material, 2D material, 1D material, and 0D material. If you move to the organic material, you can see crystal and molecules, naphthalene, and multiple molecule material file are present. In 3D material, you can see conductor, insulator, layer material, magnetic material, metal oxide, novelty material, semiconductor material. In conductor, pure metal, you can see all elements are present on element material present. In the same way for the insulator also, like diamond. In layer material, you can see multiple material has been present like WSE2, MOS2, and in the same way magnetic material also present here. Metal oxide also present, you can see, and novelty material like perovskite, topological insulator, and half metals. In the 2D material, you can see novelty material like black phosphorus and graphene structures. In 1D material, you can see the nanotube with different Roll vectors. And 0D material, like here you can see molecule, amorphous and crystalline. Let's import the 3D material, semiconductor, and move to the silicon first. Here you can see our software support multiple material format like XYZ, CIF, postcard, SCF.input, relaxation, and molecule PDB format. Let's import the silicon first. Here you can see our silicon has been imported in our GUI. If you have CIF file, you can also import by move to the import local. And in download folder, I downloaded the CIF file. Let's import first. Here you can see, you can also import your CIF file also. At here, you can also see import online option also. Click on the import online. Here you can see it connected basically through the material project API. Basically search any material like MOS2 and search. It connected through the material project with different space group. All MOS2 I have been given. You can see MOS2 with different space group. If you move to the top one, you can see here the property also. Let's drag more. And you can see the different space group and their properties also. You can see the multiple space group are also present. Click one and click on the add button. You can see here MOS2 are material imported in our GUI. You can also delete the atom by right and left click of the mouse and drag. You can see all atoms are selected. If you see above, here is the delete atom. Click on this. It basically delete the atom and left click of the mouse and drag. Here you can see center along A and along B and along C. Click on the center. Basically, create a molecule in the center of the unit cell. In file option, you can see new device and crystal. If material is not present in online also and in on and local database, you can create your own material file by clicking on the crystal. Here you can see it created the new window with crystal with different space group. You can see multiple space group are present. Let's create a NaCl structure. With 5.62, give the value for ABC, for SIG also 5.62, and also for the beta 90 degree, and for gamma also. You can see P1, P2, and P3 are in the fractional coordinate. You can also see here the plus button. Click on the plus button. You can see by default here carbon is selected. By clicking on the carbon atom, it's open the periodic table. You can see here select for the sodium. You can see Na, click it and move to the OK. You can see our sodium has been selected. Move on the plus button for adding more atoms. Let's for the 4 sodium atom and 4 chlorine atom. And change their coordinate also. By double click, you can enter your value also. 0.5. Here also 0.5. Then for the third atom, 0.5 for the P1 and 0.5 for the P3. For the fourth sodium atom, P2 will be 0.5. Let's add more atom for the chlorine. Here you can see it's by default sodium has been selected. Let's change this by clicking on the sodium atom. It will open the periodic table, move to the chlorine, then OK, and create 3 more atoms. Yes. Then give the value like 0.5 P1 for the first atom. Then in second for the chlorine atom 0.5. Then for third atom, enter 0.5 at the P3 value. Then in last atom, add 0.5 for all P1, P2, and P3. Let's say from the top. First, we have selected the add element Na, then enter the fractional coordinate like P1, P2, and P3. We selected 4 sodium atom and 4 chlorine atom. You can see the fractional coordinates also, like in the second 0.5 for the P1 and P2. After that, in third atom, we selected P1 0.5 and P3 0.5. After that, in fourth sodium atom, 0.5 for the P2 also, and 0 for the P1 and P3. After that, we selected the fluorine, where P1 and P2, P3 are for the first atom. P1 will be 0.5 and P2 0 and P3 0. In the same way for the second atom, P2 are the 0.5, and in the third atom, 0 for the P1 and 0 for the P2 and 0.5 for the P3. In the same way for the last atom, you can see 0.5 for the P1 also, 0.5 for the P2 and 0.5 for the P3. You can see by clicking on the preview option, you can see your crystal also. It basically creates a primitive cell. If you move to the click on the conventional cell, you can also preview your structure. According to your data, you can change the space group also and Brevis lattice, and then enter fractional coordinate and create your structure. Then build. You can see by right click of the mouse, you can move your crystal also. Here you can see the home button. It basically is for the plane like 3D viewer, XY view, XZ view, YZ view, YX view, and ZX view. You can create or material complex material using the crystal builder. In the same way, file in new option, you can see device also for creating your device. If you move to the device, you can see like 6 probe devices like left and right electrode, left, center and right, bottom and top, bottom, center and top, front and back electrode, front, center and back electrode. Let's move for the LCR first as an example. Then OK. You can see left electrode, center and right electrode. You can import material directly from here. Let's select indium arsenide as an example. Here and open. Same for the right electrode in material folder, 3D material, semiconductor, indium arsenide. Material, and let's select the center region as a silicon. You can see the mismatch match also, and you can enter your left electrode, center region and right region. You can preview. You can see it created the structure like left electrode, right electrode and center region. If you move to the advanced option, there are multiple surface vector and multiple things are present. You can enter your value and preview and build. Basically, it created a device structure like left electrode, right electrode, and center region. In the same way, if you move to the new option, you can see device has been completed, crystal also. You can see molecule. You can create your own molecule from here. Click on the molecule. You can see it created a new window. From the build, You can also see molecule 2D. First, let's go through the molecule 2D. If you click on the molecule 2D, you can see it created a new window with name molecule 2D. You can see the multiple fragments are given here. Let's import one. Select this and import. You can also see here single bond, draw single. Click on the corner option and it created like a structure this the same way. You can also replace this atom with other atoms also. By above atoms, you can see choose element. Right click. It will open the periodic table. Let's select hydrogen here and replace carbon with hydrogen by clicking on the carbon atom. You can see you can create a complex structure using molecule 2D structure and see their properties also here like lone pairs, radical electrons, and apply data. You can see it created a 3D molecule. At the above, you can see force option. Basically, it optimizes the structure like universal force field, gradient amber field, force field calculation, G chemicals. Click on the gap and it's basically optimize your molecule. It takes some time. You can see it change the bond length and some angles and optimize your molecule. In the same way, if you move to the build, you can see molecule. Here you can see you can create your 3D molecule here. At the top side, you can see plus button. You can see add atom. Let's go for the carbon. You can see carbon single atom, double, tetrahedral. Let's go for the tetrahedral. Right click on another atom. You can see it creates complex structure like this. And apply data. You can also apply force field in this molecule to optimize the structure. In the same way, build option molecule. You can import your 2D molecule also here. Like molecule HW, which C6H6. Let's import it. You can also replace this atom with other atom like nitrogen. You can see. And you can see here add hydrogen. You can also add a hydrogen by double click on this. And for the third nitrogen also. And you can see also the XYZ coordinates and the bond tab. Here you can see 1 and 2. You can modify the bond also like single bond, double bond, triple bond, and resonance bond. And you can also change the bond length also. By fixing one atom also. like fix atom 1 and increase the bond length. Atom 1 is not moving, you can see. And let go. Okay. You can see here angle, modify angle. If you click, you can also modify the angle between them. Like atom 1 rotate group, atom 2 translate group, atom 3 rotate group. You can see switch in the bond angle also by fixing one atom. So, and you can atom 2 also be fixed, and you can see the third atom will be moved, angle will change. Here you can see multiple ring fragment are also given here, and biomolecule also present here. You can see apply data and apply force field. You can also import your material by clicking on export option. You can see in multiple format like HJW files also, image, XYZ, and CIF files also. You can see here like HJW files, image, and CIF. Let's move for the CIF and store on the download and save. You can see we also exported our material file in the CIF format. In the build option, you can see interface builder also. In the build option, you can see interface builder. Like here, structure A, structure B. You can import your structure also by clicking on this. You can import your material. You can see here material file like 3D material. Let's go for the conductor this time. You can see pure metal and go for the silver and open. And for the structure B, again go for the conductor and this time go for the gold. Then open. You can see the grid size also for creating supercells and scan angles from 0 to 180 and increment at the 4 degree and strain range at the first surface. Let's go for the match. You can see the mismatch is 0.12 percentage and angle, total number of atoms, theta and strain theta, and click on the preview option. You can see it creates the heterostructure between two material. Then go for the build. Again, I repeat the same thing. Go on the interface builder, create between two different materials. Click on the interface, and by clicking here, or if you imported material here, you can directly import from here, or from this you can browse to this any material file and import your material. Then same for the structure B, and you can see also your surface order in X, Y, and Z direction. And according to your data, you can input your data and extend first surface, second surface, and both surface. And you can edit the range also. Then match, then preview for the interface builder. In this, if you move at the below section, here you can see cat to atomic to create multiple heterostructures. Structure, you can see here add a rectangular item, add again, and if you move to the calculation, it will open the new windows like fill junction with atom, where we define the material for each structure. Like you can also select from material folder also. Conductor, pure metal, then go for gold, and in the same way for the second structure, go for the 3D material, then conductor, pure metal, and let's go for the silver system, and again go for gold, 3D material, conductor, pure metal, and gold. You can see the direction also and define the length like 0.5 in nanometer. 0. Let's go for the 1, then 0.5, and you can create size into hand range and hand range into create a supercell, and rotation also, and click on the preview option. You can see it create a heterostructure, gold, silver, then gold. So increase the click on preview. You can see click on build. On cat to atomic, you can create a complex heterostructure by clicking multiple and assign different material, and move to the calculation and assign the material file here and length and direction, and create a supercell, then rotation and strain, then click on preview, then build. In the build option, you can see the crystal. We go through this to create an NaCl. You can also click from this, and you can see here the redefined crystal. If you move over the silicon and build, then redefine crystal, you can see ABC. If you click on the face center, Then preview. This is space centered silicon. Click on build. You can see it created. You again move to the build and redefine crystal. And in the C direction, let's increase this and create supercell. Like go for the 10. Then preview. You can see in the C direction, it created supercell. In any direction, you can like go for the 3 and preview. You can see it creates supercell. Then build. In the property section, you can see the total number of atoms, total area of lattice, and chemical formula also. And from this, you can view a different XY view, XZ view, YZ view, YX view, and ZX view. If you click on the single atom like this, by clicking left button of the mouse, you can delete this atom. You can see it created a defect also. And if you want to delete multiple atoms, drag with left click of the mouse and drag like this, and it will select multiple atoms. You can see, and click on the delete atom. You can see deleted the all atom. In the same way, if you want to replace atom with other atoms, click on one atom, and here you can see replace atom option. Click on this. It will open the periodic table. Click on any other elements like nitrogen. It will change to the nitrogen atom. You can see it shows a different color also. If you see the properties, click on this atom. You can see in the properties section nitrogen value, element nitrogen, and their XYZ Cartesian coordinates. The same way, build option. You can see the surface and slab option. For creating the surface with Miller indices, you can see, and also add the slab also. Then build. Again move to the build. Then surface and slab. Also add the vacuum also. Then build. It basically created a surface also and vacuum layer. If you move to the symmetry option, it basically gives the properties of crystal. You can see name, option, and tetragonal shape, and their operator also. Move to the build option. Here you can see standardized cell. It basically create a primitive unit cell of any conventional cell. Like click on the standardize. It basically create like this one conventional unit cell. If you move to the build, then standardized cell, it create primitive unit cell for this. You can see in the build option, you can also see graphene nanoribbon and nanotube. Click on the nano ribbon. You can see site A and site B. If you click on the carbon atom, it will open the periodic table. By clicking any element, you can choose. By default, you can choose carbon one this time. And you can also assign the bond length and passive it with bond with hydrogen atoms. And let's go for the graphene armchair, and will be 4, then 0. You can see it get graphene armchair. Let's build. For the better visualization, go to the XZ view. And by clicking on this, you can rotate also. XZ view. Again, go to the build, then redefine crystal. In C direction, let's increase the length and create a supercell. Like go for the 10 and preview. You can see it create graphene structure. Go to graphene structures. Then build. For the better view, go for the ZX. You can see hydrogen passivation also percent. Again, for the build, go to the graphene nano ribbon. You can see, let's create for zigzag graphene here. Decrease the N and let's increase 2 and cross M will be 2. Then preview. If we unclick this one, then preview. You can see it created a zigzag graphene. Then build. Go for the ZX view. YX, YZ, XZ view. Here you can see hydrogen plus. Let's hydrogen passivation form also here. You can see it passivate the atom. Again, move for the build option and redefine the crystal. In the C direction, increase, then preview. And see again build. You can also left click of the mouse and drag and select all atoms. And right click of the mouse, you can see copy option. Copy this and move for the armchair graphene. This one. And paste here the zigzag graphene. You can see. Left click of the mouse and select zigzag graphene. And you can see here move atom. Click on this. You can see translation along XYZ, unit cell vector, and along screen view. Click on the screen view and assign some distance like 0.5 angstrom and move the atom. Let's undo this first. Section. First, paste it. Select all the atoms and click on the center. You can see it creates complex structures, and by moving the atoms also you can above create 2D structure, heterostructure like graphene heterostructures. You can see here plus icon also for add extra elements atoms like nitrogen. You can see it added the one atom. By selecting all three elements, left click of the mouse and drag it. It selected the all four atoms. And the last option you can see here, recalculate bond, recalculate linker bond. You can see it create a bond between this. You can see. Let's do again by clicking add atom here. Add any elements and place. And you can also move by clicking this with the screen view, unit cell, and XYZ. Select by clicking left click of the mouse and drag. Here you can see recalculate linker bond. Click on it. It created with one atom only because the distance between two atoms are very large. That's why it not created a bond in between two atoms. You can see it's a zigzag graphene structure. If we move to the last option, here you can see convert to device. You can see left electrode, right electrode, bottom electrode, top electrode, front electrode, back electrode. Click on the left electrode, right electrode. You can see the length also. You can also increase by double click on this and change also and move to the preview. You can see it created the electrode region like left electrode and right electrode and center region. You can see it creates graphene two probe device. You can also change the length also here, like go for the 4 and again here also 4 and into the preview. You can see it increases the length also. Again move for the build. It created a device structure of nano ribbon. In same way graphene nano ribbon, you can see you can change the element also. Let's go for the antimony. And you can also change the bond length also here and structure type and then preview. You can see for different element you can also create it here. Again build and YZ view and move for the ZX, then build, redefine and enter 10. And also You can increase the, you can move to the point. You can also change the, move the atom, certain atoms by clicking on this. It will selected all the previous atom, back atoms, and you can move, and you can create disorder structure like this. You can see it move it 0.6 angstrom, then 0.6 angstrom also. In this graphene structure, you can also create the defect like point defects by deleting one atom, and find properties also, and you can add or replace atom with different, like replace with other elements like nitrogen, and find the doping properties also before and after. And you can also add atom like go for the oxygen and select and go to the recalculate linker bond. You can see it created a bond. You can also move the atom at certain x and y z coordinates and find the doping concentration properties, doping properties before and after, before doping and after doping. And in the build option, you can see graphene nanotube. You can also create nanotube here. Like here, you can also see in the same way graphene nanoribbon like carbon A and carbon site A and site B. You can see by default here carbon is selected. You can change by clicking on this. It will open the periodic table, and you can choose any element according to your need. Let's take by default and go for the 3x3. Again, move to the preview option to show the structure here before building. You can see it created the nanotube structures. Build. Again, move to the build and redefine the crystal in the Z direction, in the C direction with 10. Again, preview. You can see it created nanotube structure. Move to the build. It creates nanotube structure. Again, move to the build option. Nanotube. This time, let's go for the 5x5. And preview. You can see it created 5x5 carbon nanotube with different core vectors. And move to the build option and redefine this 5x5 in the C direction with 10. Build. By clicking on this, we will move to the standard version and left click of the mouse and select all atoms. And let's replace this atom with potassium. and okay, you can see it created potassium nanotube. If you want move to the 3 cross 3 nanotube in between, like create cylindrical structure, go to the 3 cross 3 nanotube and click on the home button and left click of the mouse and select all, then right click. You can see here copy this and move to the 5 cross 5 potassium nanotube and move to the home and right click and paste. Select and move. Here you can see center. You can see it create 3 cross 3 graphene nanotube, then potassium nanotube. You can create complex nanotube also here and find their properties also. In the same way, in build option, there is a nanotube option. You can see with different chiral vectors. In the build option, you can also see disorder graphene structure. Basically, in this order, you can change the bond length and angle also. You can see like site A and site B with carbon atom. You can also change by clicking this and select any atom, any element. In the same way for the site B also. And for all 4 carbon atoms, here also you can change. Let's go for the 8 cross 8. And you can change also the bond length. Again, preview. You can see it created a disordered graphene structure. Build. By changing any other atom with this, like go for the silicon. You can create disorder structure, graphene like structure. Again, move to the build option and you can see the disorder zinc blend like structure. You can see here carbon atom by default it is selected. You can change the bond length also and create supercell. You can see. In the build option, you can see icosahedron with 20 triangular faces. Like create a multiple cell also and with one cell also. By default, carbon is selected. Again, move to the flip. It basically 20 triangular faces are present in icosahedron. And you can increase the cell also by increase and preview. You can see again build. and you can see Cuba octahedron by default carbon present preview Cuba octahedron. You can see you can create using this tool and increase the cell also and build. You can see it's basically a crystal. You can also convert to the molecule by selecting left click, and here you can see here convert to molecule. You can see it converted to the molecule. No unit cell present here. It converted into the molecular form. Again, select all, and you can convert to crystal. You can see here in center. It's so convert to crystal. Click on this, and by defining primitive vectors x and y in z direction, that's 20 angstrom, 25, and 40. Can convert to crystal. By default, I have no any value, so that it not converted to the crystal. Let's select silicon, which imported earlier. Here you can see the simulator option. In simulator option, you can see there are multiple tools present, like nanodecay for the device and material simulation with small exchange correlation, nanoscale for the tight bonding, and rescue for the material simulation software with multiple exchange correlation, hybrid exchange correlation function, which based on DFPT and density functional perturbation theory. You can see here rescue, and you can see here SCF calculation, self-consistent field calculation. Click on this. You can see it created a new window, SCF calculation for crystal. You can see here basic setting like simmering sigma in 0.01 electron volt. By default, it will take value. You can also change by clicking on this, and you can see here the method with real space and LCO, linear combination atomic orbital. You can see here exchange correlation function. If we move, you can see here local density approximation GGA, LDAPZ, LDA, GGA. You can see multiple hybrid exchange correlation, meta GGA. Let's go for the LDA first by default. Here you can see K point sampling. You can change. If you increase the value, it takes some time. Let's go with the default value. Again, move to the iteration control. Here you can see tolerance value for the charge density and total energy, and maximum SCF step like 2000 or 200 iteration. You can see here 200 iteration. You can also change here. If the atoms are large, you can increase. Let's go to the default value 200. You can also see mix method, Pole, linear, Croydon. Go for the Pole option here. Mix variable also here you can see density matrix and potential, and mix history and eigen maximum iteration with 15 value. You can also change according to your input data. Then basis set. You can see here arrangement by element, and you can see here LDA plus U. If you select it, you can see SPDF will be open. You can take your value. Award will be taken when transition element will be chosen. By default, let's unclick it. Here you can see basis set. Here double zeta polarized, atomic data, and user defined. You can also import your basis set by clicking on this. If you click on the user defined, you can see it will open pop-up. And if you move to the device studio, here you can see pseudo potential also present and neutral atom database. In general, you can see pseudo potential are given for the silicon and other elements also. Let's go for the by default double zeta polarized. And in spin type, you can see spin type no spin, collinear spin, and general spin. If you move to the collinear spin, you can see you have to enter your value, maximum, and arrangement by element. And you move for the general spin, you can see maximum, pi, and theta, and spin orbit coupling also include. For time being, let's go for the no spin this time and click on generate file. You can see in the project window here at the left side in Project Explorer, you can see it created a folder like silicon, then rescue crystal. In rescue crystal, you can see SCF input file has been created and atom.xyz file has been created. In SCF.input file, right click. You can see run option, open with, and open containing folder. Click on open with. You can see it created a script using our GUI with SCF calculation. You can see like for calculation type, self-consistent, where our result has been stored, like result in silicon SCF, symmetry, space symmetry, icon solver, and K point sigma, all default value which has been chosen earlier, like mixed type, density, mixed method, Pule. And you can also edit this by clicking on this and save this by this. And atom.xyz, you can see here, it basically tell about the Cartesian coordinate point of the atom, like of silicon. You can see here the two silicon atoms and their coordinates point. SCF input, right click, then click on run. You can see here gateway location. By default, my system has been selected, and click on run option. You can see it created a silicon job status. Close this window. In job manager, you can see our script has been running condition. You can see also process here. By clicking on this, it will open the silicon job status. It will start it. Let's close this part and move to the simulator. Then rescue. Here you can see relax, DFPT, and analysis. Go for the analysis. Here you can see for the analysis, here multiple parameters are present like density of state, band structure, molecular population, and potential. For the time being, let's go for the band structure and density of state. If you click on the band structure, their parameters are given. You can see symmetric K point. If you click on the path, you can see Brillouin zone path will be open, like U and X, G, W, and their value. If you click on any of this, you can edit also value. Sorry. And you can delete also by clicking on this. Delete, delete, delete. And you can move also up and down, like G will move to the top side, and U will be below, and X will be below side. And click on the preview option. Click the G value and let's apply. And you can also see the number of K point. If you click on the total, it will be increased. And here you can see wave function calculate and partial weight band calculate. For the density of state, if you click on the density of state, it will open density of input parameters like k point sampling. Let's increase t, t, t. And you can also change the energy range also. Let's go for the 5 to 5 minus 5 to 5. And number of energy point and k point sampling. You can see Fermi direct, Gauss, tetrahedron, tetrahedron plus log. According to your data, you can choose and smearing sigma and generate file. You can see it created the band structure. Band structure dot input file, density of state dot input file. Right click, open with. You can see it created the script for the band structure dot input file, like linear combination atomic status is equal to 0, and where result has been stored, and k points, symmetry points, and grid point. Let's close this window. In the same way, it created the density of state input file, open with, and by default value, all are given like k point, 3 cos 3 cos 3, and Fermi direct, and energy range you can see minus 5 to 5. You can also change from script also, like here. Let's go for the 10 cross 10 again, and save this, and click on the band structure input file, right click, run option. The same way for the density of state input file, right click, run option. You can see our band structure input file in queue condition and density of state input file also in queue condition. The first input file will be running condition. You can see it started. You can see also the job status. It's begin the self-consistent calculation here. You can see all by default parameters are given, like generating local potential, initial density, then create Hamiltonian, and calculate real space wave function. You can see it started a iteration process also here. You can see computing non-local forces and local pseudo-potential forces also here. And our SCF input file has been completed. You can see finishing self-consistent calculation. In the job status, in job manager, you can see our SCF.input has been completed. You can see here. Now it's band structure.input in running condition. You can also clicking on this to show the process. It will take some time. Again, move to the simulator, rescue, and analysis. In band structure, let's go for the partial weight calculate. You can see here. Generate file. It creates band structure partial weight dot input file. Open with. You can see it created the script. Let's run it. It's also file. Run. If you see at the corner, right corner side, you can see here. You can connect to the server also, your high-end system also, by clicking on this new and giving the computer name, IP address, their sources, and working directory and script directory. You can connect to the high-end system also. I'll show this. You can see finishing band structure calculation. Our band structure dot input file has been completed. If we click on the band structure.input file, open containing folder, it will open the file path where your file has been stored. You can see all input file has been here. You can see here result folder has also been created. Click on this result. You can see band structure.txt output file has been completed, like density of test, density of state, potential are generated. Let's visualize this. You can see also here the sqlog.out file has been created to see how many time it had been taken to run this simulation. You can see here time calculation and all running data. It will store in the sqlog.out file. Again, move to the simulator, rescue, analysis. Sorry, analysis, not analysis. Simulator, rescue. You can see analysis plot. Move to the folder where project has been stored, like in C drive. Launcher. Launcher. Tell. Then move to the document. And you can see a device studio project. And our project name has been hands-on training. You can see here silicon, rescue crystal, results, and band structure.txt file. Click on this and open. Take time.
So today's sessions we have discussed about the rescue softwares and the other GUI and what is the actually user interface at the device studio. We have different softwares like rescue and analyticals. So today we are discussing generally rescue softwares. So if you have any query related to the rescue softwares, anything is that you want to ask, so it is open to all. Please ask your query.
I have one question, that is how to export the data, that is for DOS and bands. If I want to plot in some other software, that is Origin or Excel.
Like if you want to export your data, so we have that option in the device studio, like online, and directly you can export your data. And like you are asking about the PDOS and LDOS, so it is on the analysis plots. So it is come on the analysis tabs. So then after the exports your projects like material file, any files, then you can move toward the analysis parts. So in the,
Okay.
yeah. Anyone else that want to ask? Someone is asking, device studio software is free, how we can download it? We have already provided their download link in the WhatsApp or emails, so you can
Hello, sir.
download from there. Yeah.
Sir, can you please share the recorded video for this
Yes.
for this session only?
We will provide, sir. We will provide. And in the YouTubes, we have also a lot of the video related to the nanodical and rescue. But in this recorded session, we will definitely provide to you, sir.
Okay,
Please
sir.
wait.
Thanks. Thank you, sir.
Hello.
Yes, sir. Please. Jesse Angle, sir.
Yeah. When I select the atoms, they are getting selected, but then it doesn't change to a yellow color.
Ma'am, I think you just select only the press right clicks on the mouse. You need to press the control and then hold also that buttons. Then you can select different atoms. And if you want to another process second, you need to drag with the left click of the mouse pen.
Okay.
Then you can select more atoms.
No, I'm able to select, but then it doesn't change to a yellowish color.
If you are unable to select, so we need to contact you surely
Okay.
at the separate way.
Okay.
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 Yes, I have another question, that tube can
Yes.
it
Yes, ma'am.
design for other elements also? That is for boron nitride or silicon germanium, this type of systems.
I want to know when you.
Yes, ma'am. We have that elements also.
That is not carbon only, that is with some two atoms, like gallium arsenide or boron nitride, this type of
लैब में है कोई?
Yes, ma'am. We have that.
लैब में
We
है
have
कोई?
that gallium arsenide, and if you have that not in the material file, we can directly import through the online also.
अभी आपके पास है?
Okay, can you show one time the that is with two atoms,
Okay.
how
Ma'am.
it is possible
Wait.
in next
Wait, ma'am.
lecture or other
I will
lecture?
see. Okay. Wait, ma'am.
Hello, sir. Hello.
Yes, sir. Please wait. That we are connected with the Ujjwal also. They will share out the device studio. I'm Sahil. I'm listening for the query in here. So now screen is digital, sir. Please ask one by one so we can respond good way.
Yes, sir.
Sir, I want to know when you will be providing
Two atoms, with two atoms.
recorded lecture of the session. Hmm? Hello, sir. When you will be providing a recorded lecture of the session.
Sir, we'll provide after the session. And redefine it. Then preview and bed. And for the carbon nanotube, you can create like this gallium arsenide carbon nanotube and build, and again build. Go to the build option, then redefine crystal and increase the length. You can see it create graphene gallium arsenide nanotube.
Okay, okay.
And the result I will show self-executed. You can see a band structure. Go to the simulator, press analysis
And
plot.
and any structure can be converted to molecule as well as crystal.
Yes, ma'am.
Okay.
You can see here three options are given: convert to molecule, convert to crystal, and convert to device.
Device means that is two probe system.
Yes, ma'am. 2 probe and 6 probe device, up to 6 probe device.
Okay, okay. But one thing that you are providing only with one core, then how it is possible to run two probe calculation? In one probe, in one core it will not complete. That is two probe calculation is time consuming.
Yes, ma'am. It will take time, but you have to move to the cluster also, or cluster installation.
If you kindly provide at least 4 cores, then it can be tested. Is it running or not? In one core, it is not possible to run the transport calculation.
For
It will take
hands-on
huge
training,
time.
for hands-on training, we will only provide one core also by parent company.
Yes, you provide only one core, and it will. I am saying that it will not complete in one core. That is transport calculation.
So it will take
At
time,
least,
but will be completed in one
if
to 2
possible,
days.
at least you can provide 3 or 4 cores. Then we can test very nicely. Okay, this one suggestion, my end.
Okay, sir. Let me see the result which has completed. Analysis plot. See that future.
Hello.
Document. Device studio project. Hands-on training.
Hello.
You can see. Yes.
Hello. I want to know. I want to know how many cores are at least required to run this software.
Basically, sir, we recommend 16 core and above. For TFT basically depends on the number of atoms you have taken. Yes, sir. And if you have high-end system and cluster, you can also switch to the cluster also and run your simulation.
I have a system which has 4 cores and 8 logical processors. Will it run smoothly on that system?
So it will take time, but it will run.
Yes, that's also my question. In one core, how it is possible to run and see the results clearly?
You can run number of atom, decrease the number of atom, and you can run. You can see the band structure. The result has been completed here. Band structure.input file. You can see band structure, and you can also save this by export in image format, text format, and in the same way, rescue analysis plot, and you can see here density of state also. Click on density of state. Open. You can see also the result of density of state, and you can also export in image format, multiple image format.
हेलो आरती, आप क्यों हंस रही हो? क्यों हंस रही हो? भैया,
And you will move to the folder where project has been stored. Document, device story project, and hands-on training, silicon, rescue crystal. In result option, you can see here .mat file also present here. You can also open in MATLAB and see the result also. And H5 data well also present, and band structure in .text format. Anyone have doubts?
hello sir.
Yes, sir.
Hello.
How many
Yes, sir.
codes are at least required to run the software smoothly for efficient running?
Above 16 core.
Above
Hello.
Sir, up to
16
above
core.
16 core. Yes, sir.
Hello.
Yes, sir.
I want to design the MASN BR3.
What, sir?
I want to design MASN BR3, methyl ammonium tin bromide perovskite structure.
Yes, sir. You can create
How it can be possible, sir? What
Sir,
parameters to be needed and how it is possible?
if you move to the file option,
Yeah.
you can also import online. It will be present in material project. Sir, please give the formula.
MASN BR3, methyl ammonium,
MABS,
that is CH3NS3, CH3NS3, SNBR3,
SN,
CH3NS3, CH3NS3, sorry, CH3NS3, CH3,
and yes, sir.
NS3, NS3,
Yes, sir.
SNBR3,
SN,
SN, SNBR3,
SN antimony.
teen, sir, teen,
Okay, and BR.
BR3, yes, bromide.
Basically, it will not in material project. Then you can move to the file and new and crystal. And here you
Right.
can see by defining the fractional coordinates, space group, and Brevis lattice, you can create your material here, the crystal here.
Mhm. So how can I design, sir?
So by giving those input data like with space group and Brevis lattice, then element by clicking on this, and you can change like C by clicking on add atom, and you can change with hydrogen and enter their fractional coordinate like CS3, then SN and BR3 and their fractional coordinate. And if the material file is present online, you can also import in multiple format also. You can see here. Import local. Material format has been supported by our software like XYZ, CIF, postcard. If it's online project, it will be supported multiple material format.
But if it is not available, sir, we can design it, no?
Yes, sir.
But I have to find the what parameters.
Yes, sir.
So what parameters to be needed, sir? The bond length.
Click new crystal and the Weber lattice and space group and their fractional coordinates.
So coordinate needed and the bond length and index.
No, sir. Only space group, then Weber lattice and their angle alpha, beta, gamma, and fractional coordinates.
Sir, actually the elements what you have to write here, sir?
What's it?
Elements.
By clicking on add this atom, you can change. You can add multiple n number of atoms here.
Suppose I want to write CS3, na? CS3 means how can I write, sir? The compound.
C, then H,
CS3.
then H,
Ah.
then H. And give their fractional coordinates and then create your crystal here. So also share the chemical formula so I can search and tell this about more.
Sir, okay, sir. So I think, but you can able to say me, sir, how it can possible, sir.
Okay, sir.
Okay, sir. Thank you.
Anyone else?
Sir, how to increase number of cores in this software? I am not able to increase the number of cores. It's showing only one core.
Yes, sir.
available.
For hands-on training, we will provide only one core.
So, sir, how to avail the software fully functional software then?
For that, you have to purchase the software.
What is the cost of this software now?
So it will depend on the number of years and number of license.
Okay, so currently the software you have provided, we can only use one core only. We cannot use a fully functional.
Yes, sir.
software.
Yes, sir.
Okay. So it is basically for basic training purpose,
Yes, sir.
basic practice purpose.
Yes, sir.
So may I know the price for 1 year, the software?
For the 1 year, 1,75,000 plus GST.
Also, sir, like, is this software available in Linux or only for Windows?
Sir, it's also available for Linux.
So, sir, if I want to use GPU in place of CPU for the calculation or computation, so how can I use that? Do I need to have Linux software, or I can also use GPU in Windows as well?
So basically for cluster installation, we need only Linux.
No, I want to okay, I want to use CUDA based basically graphic card for computation, not CPU. So
Yes, sir. Rescue support CUDA, but on cluster basis. If you purchase cluster license, then.
And for the CUDA use, I need to have Linux or Windows.
Sir, Linux.
Okay, I need to have Linux software for CUDA.
Yes, sir.
Do you provide also the compilation code, or I need to compile on my own?
Sir, you have to compile your own.
You will just provide source code.
Yes, sir.
And hello.
Yes, sir.
And sir, will you be providing assistantship in like installing the software in Linux, like how to
Yes,
compile?
sir.
how to
Yes, sir.
compile it.
Yes, sir. We totally provide technical support.
Okay, so
How
right
to the-
now you are having a Linux software with CUDA support also, right?
Yes, sir.
Okay. So you will help in compilation for the Linux.
Yes, sir. My parent company will help them.
Okay. For the Linux also, it is having the same cost, uh, or it is having a different cost for Linux software.
Sir, you have to contact to the sales team. They
Okay.
will better guide you.
Okay.
Anyone else?
Hello.
Yes, sir.
Like nanotubes, can we design spherical particles in this software?
What, ma'am?
Like carbon nanotubes, as we
Yes,
can
ma'am.
design that. Can we design a spherical particle?
Ma'am, not spherical, but icosahedron, octahedron, this type of shape you can create.
No, like nanotube, we can design a nanoparticle shape like that. Can we design some other shape?
I have to check, ma'am. Then I will tell you.
Okay, okay. Please let me know.
Okay, ma'am. Okay, thank you. See you tomorrow.